right, well, we'll go ahead and get started. Just want to welcome everybody. My name is Juanetta Ayers. I'm the Executive Director for Commonwealth North, and welcome to this Friday noon meeting of the Energy Policy Study Group. Just a couple of housekeeping items, since it does look like we are going to have a smaller group, so we probably can just open up cameras and microphones and have more of an open discussion later on after Darron's prepared remarks. We will have Q&A, so again, we'll use either the chat feature, or you can raise your hand with the reaction button, or open your camera and raise your hand and I'll call on you. And with that, let me just toss it to Bernie Smith, who's co-chair of the Energy Policy Study Group, along with Marianne Pease, who's joining us on the phone from Seattle. But we'll toss to Bernie and let Bernie introduce our guest. So Bernie?
Yes, again, I'm Bernie Smith. I'm one of the co-chairs of the Energy Policy Group and on the board of Commonwealth North. And so welcome to everybody. And I would like to welcome Darron Scott with the Kodiak Electric Association. They put together an amazing renewable energy policy down in Kodiak. Darron said that they have been diesel-free since for 7 years now, with the wind farm that they have on top of the mountain up there, plus their hydro. And it's amazing that we have a large utility, so it's a fairly large utility, covering the whole city of Kodiak, to go renewable, and especially with diesel prices right now. So with that, Darron, you can take it off.
Okay. Just go through my presentation, and again, I'm pretty open to any kind of dialogue that y'all want to have through it. Just a little bit the background here, and probably a lot of y'all familiar with Kodiak, but just talk about our again, we're an island, and we're an islanded grid as well. Our big customers are electric loads, are fish processing, and the whole fishing industry in general. And fish processing directly takes about a third of our electricity, just those 6-7 fish processors that we have here on island. And then the Coast Guard base, we have the nation's largest Coast Guard base here, and that's just under 20% of our power directly as well, between all the housing and all the other different things they have there on the base. And so that, and then the rest of the town is pretty much support services, schools, hospitals, and housing and everything else for those two basic industries there. So a little bit about KEA. Again, like most utilities in the state, we're a locally owned electric cooperative. Owned by our membership here on the island, and we've got about 6,000 meters here. We're an isolated electric grid, so a little different than the rail belt, but more like many other communities all across the state. So we're an island in itself physically, an island electric grid, so we're not connected to Homer or anybody else. Everything we do here, and that makes you focus a lot on system frequency when you're looking at putting in variable renewable power like wind turbines or solar, those type of things. Kind of the key with electricity, and it makes it a different commodity than just about anything else. And I'm sure y'all probably know all these things, but we have to make exactly what our customers are using every millisecond. And if we get out of whack on that, things can get pretty bad. So that's what makes an islanded grid kind of special, especially with variable renewable energy. Peak load's about 28 megawatts, min load's about 9 megawatts. So and really the min load's more the concern when we have actually 9 megawatts of wind too. So we have to kind of keep an eye on that as well. So kind of taking back historically.
Excuse me, Darron, do you have to curtail your wind at any time?
Very rarely. What we do with that is the only time we really curtail it, other than some really strange situations, is we want to keep 5 megawatts in our hydro plant. Okay. And that's for not just so much efficiency reasons, but grid control reasons. If we get too far out of whack from that, we don't want wind to take over the whole system. Wind can be very kind of funky when it comes to voltages and stuff by itself, left alone. Sure. So we want to make sure that the master of the system is the hydro plant. So if we're in a situation where our loads are down, say below 14 megawatts, and we have full power of wind, the wind will automatically curtail to make sure hydro stays at least at 5.
Thank you.
Sure. All right. So back when we were in 2000, we had just completed a combined cycle plant that was going to run on diesel fuel. It was actually built on the Coast Guard base, and our future was going to be diesel. With that, we were back in 2000. We were basically 60% diesel, 40% hydro. All our load growth was built into that combined cycle plant. So we were going to be doing that. And hydroelectric, our Terra Lake hydroelectric plant was actually owned by the state, and then was connected through the Fort Ann Pool group as well. So everything, so it kind of like Bradley Lake is now, but we were just, we operated it ourselves, but it was in a pooled environment with the state of Alaska and a few other hydros and utilities across the state. So very different arrangement than we have today. So this was back at this time, 2007. This really started kind of more like 2003 or 4, but we finally got to this point in 2007. The board approved this vision, and we've been basically under this vision. We've adjusted a little bit, but under this vision since then. And I really want to applaud the board for this type of vision, and also staying with it all this time over all these years. And really, this says a couple of things. One, we were going to be primarily renewable. We were going to get off diesel as any kind of big source of our power or any other fossil fuel. And then we were going to have to make it cost effective at the same time. And our definition of cost effective at the time was really cheaper than diesel was. Diesel wasn't super expensive back in those times, but it was somewhat expensive. And that was our goal from this. We were going to make this cost effective for our membership, and green as well from that standpoint. And it's interesting, the big driver behind this, looking back at what really started us down this road, it wasn't the green power, kind of the climate type situation, even though this was a positive for that. And it wasn't the cost so much as well of burning diesel. It was the high variability of diesel fuel prices. And what was happening to some of our large customers, our large members, hey, what are we supposed to budget next year? What are we going to budget in fuel prices or electric prices? And my answer back, unfortunately, was, well, what's the price of diesel going to be, and how much is it going to rain? And those were bad answers, really. And our members, they, whether it's a school district or a large processor, whoever it was, they couldn't budget because our prices were adjusting dramatically. And imagine if we were on, fuel today at 60%, and these fuel prices we're having today, there's no way we would have budgeted that last year to have these kind of really high diesel prices. And we were seeing some of those kind of fluctuations, not this bad, but in the past. And that's what drove the board and all of us to kind of move this direction. That was the first start of the snowball going downhill, which led us to where we are today. So just some picture of some of our large assets here. This is the Terra Lake itself. So this was built in the 80s with the state of Alaska. And it started with KEA built, but the project honestly got to be so big that this is the same time state kind of built some other hydros across the state, kind of took some of those over. So Alaska Energy Authority finished this up and ran or owned this facility. We ran it and got collected with utility or the hydro in Valdez, Copper Valley Electric, and then down in Ketchikan and Wrangell and Petersburg as well. So it's called the Fort Ann Pool. But it's a great plant. The lake itself is about 1,000 surface acres, and now it's 33 megawatts. At the time at 2000, we were just keeping it at about 20 megawatts. We've done some modifications since then, but it's kind of the backbone of our system here. It's a high altitude lake. When it's full, it's at 1,420 feet elevation, and our power plant itself is down almost at sea level. So we get a lot of head pressure from that. So it makes it a very efficient power plant. One of the things that's special from this, and as we do any modifications to it or work with it, that picture that you're seeing of the lake, that's all National Wildlife Refuge. So the power plant's not in it. That's in kind of state or borough land, but the lake itself and the dam that you can see kind of in the upper middle area, that's all in wildlife refuge. It makes it a very sensitive place to work.
So,
hey, Darron, this is.
Go ahead.
Go ahead, please.
Hey.
Go ahead, Marianne.
Hey, thank you. Hey, Darron, going back to the previous slide for 1 second, what is that break-even point where you look at the price of diesel and you're going, oh boy, we really made a good decision. And then if diesel is at what price, is it not as economic? So what was your break-even point for diesel?
Let me just do a quick little calculation. It's been a long time since I thought of that. Let's see. So let me do some math, kind of catching me off guard there. 10.2, I think it was about $1.50, $1.60 a gallon of fuel in that range. So the wind power is with that. I'm just going to comparing that against the wind power price, and the wind power has been very effective relative to diesel prices, especially now that we're seeing $3.50, $4, $5 a gallon diesel. But back when we were looking at this, it was kind of probably in that $1.60 range, and it's been very effective since then. One of the things that we've noticed on the diesel or wind versus diesel that we didn't realize, it's been a big advantage, and I'm kind of jumping around the slides a little bit here, but a good conversation. We were very nervous, obviously, going into wind turbines. These were the first large scale industrial wind turbines in the state. And I'll just flip over the wind turbine slide there. So there's 9 megawatts, 6 1.5 megawatt GE wind turbines up there. So we were like, we don't know how to really maintain these. This was all new to us, and we were very scared about how the maintenance was going to work on these. Well, once we actually got settled down, the first year or two was a little bouncy for us trying to figure things out. But since then we've been in a groove, and the cents per kilowatt hour for O&M, not the fuel portion, but just the O&M, the operations and maintenance of it, it's been cheaper with the wind turbines than it was with the diesel beforehand.
Wow.
Diesel units are high friction units, high temperatures. You got a lot of moving parts in them, and there's a lot of wear that goes on with diesels. And the wind turbines, while they have their problems and they have maintenance issues, just on a cents per kilowatt hour basis, they've been more effective for us in maintenance and operation than the diesels were before. So, and we had good Caterpillar, 3616 diesels are great machines and all that. But just the way that these things operate is just more effective overall than the diesels have been. So these got put in, the first 3 got put in 2009. And we did this in steps. And then we put the 3 years later, we did the next 3. And we just had to make sure we could do all the modeling right and understand these units. Because we first put these in, and these variable units in here, with the high variability of power, fluctuating up and down, we weren't used to trying to balance that on our system. So we had a lot of work to do, and I'll go into a slide here in a little bit that kind of shows some of the balancing work we had to do. And that's one of the reasons we took it in steps. And there's been a lot of steps along the way to kind of get to where we are today. But this up here, this makes about 26, 27 million kilowatt hours a year. So that's in the neighborhood of almost 2 million gallons of diesel. It saves a year for us. At today's prices at $5 a gallon, that's what is that, $10 million a year of fuel savings at today's prices. And we only invested a little over about $45 million between these and the batteries to make them all glue together and work, and the power lines, everything. And so it's been a very good investment for us and for our community over time. And what made it even better, we hit this at the time, kind of talk about policy. The Renewable Energy Fund was going very strong when we were putting these in, and we did get some very favorable grants on these and some favorable low interest loans from the federal government at the same time to kind of put this whole package together, which made it even more cost effective when we got these things done.
Darron?
Yes.
Quick question on the wind turbine O&M. So you use your wind turbines to subsidize and basically retain water in your reservoir. If you were to use your wind turbines, if you were to allow yourself to use the wind turbines as the primary source and the integration it would take to replace diesel as the primary source and not have your hydro as a base load, do you expect that O&M number would go up significantly with the integration?
I
necessary?
would not think so, no. The O&M issues we have with these units, the biggest ones have to do with the water. Like you see in the picture here, I mean, unfortunately or fortunately, how you want to look at it, Kodiak is full of rain and full of, heavy wind and moisture and ice and those type of things. That's what drives a lot of our O&M issues on the wind turbines. So it's not so much how they're used on our load. We let them run wild for the most part, and we don't curtail them or anything like that. So I think that wouldn't be much of an issue. I think where you get into more cost would be in the battery side of things, stabilizing. We'd have to have a much more a larger and probably a little bit more aggressive battery system if we didn't have the hydro plant to be there to provide the kind of the backbone that Terra Lake provides for the wind turbine stability right now. And then you'd have the diesels in the background after the batteries, I would imagine, if you wanted to try to glue all that together. So, and you'd have to have something also kind of keeping the frequency, but that can be done with batteries under some strange situations too. But I don't think the O&M on the wind turbines would really change much from that standpoint.
Darren, going back into the hydro a little bit, Brady Lake with the Battle Creek diversion has really, and the rain that we've had has really filled up the dam up there, and they've been a couple of feet below spilling, which is wasted energy. So you don't really have that problem, do you? How do you curtail the hydro when like you say, you got so much rain up there? Do you just close the? How do you manipulate the power coming into from the lake itself?
Well, okay, so the power plant down here in the left-hand corner, the water's controlled. There's 3 hydro units down there now, and they're controlled by just a series of basically kind of valve type things that inject water in. But from a controlling the overall lake level, we try to keep it. The lake can spill, and if we're in a heavy water situation, it will spill and have wasted water. What we've done on it's kind of toward the end of my presentation, but what we're doing now, no, it's fine. It's good to jump around a little bit. So we did a project very similar to Battle Creek. We call it Upper Hidden Basin Diversion. Just finished that a couple of years ago, and I'll show some pictures of it later. But in general, what that did is it provided us for a good chunk of our future, at least the near future, to have full renewables, and that's great. And so with that though, and just probably like a Battle Creek or something, when you're doing hydro work, you don't just dial it in exactly kind of, I just need this today and this tomorrow. You're spending so much money on it. This was an $80 million project. We got a lot of energy from it. So we were going to get spilled. So what we did with that, and we knew that was coming, we partnered with the school district in the borough, and we got big electric boilers put in, the swimming pools, high school, middle school, fisheries building, things like that that are on an interruptible rate now. And so if we got into a point where we were running dry in our lake, we would say, hey guys, we can't supply this anymore. We'll have to interrupt this power and you have to go back to diesel. But right now we haven't had those issues in the last few years because this hydro expansion Hidden Basin has gone so well. Someday we will, but that's how we built interruptible loads into our system to help manage that for the near future anyway.
Thank you.
Sure. So here's just a picture of the batteries that we currently have right now. We've got 2 1.5 megawatt batteries. They're lithium ion, and just we originally had some kind of fancy lead acid batteries because we were kind of new into this whole battery thing back in early 2010, 11 when we got these, and so they failed after 6 or 7 years. Got these new batteries in, and they've been operating great. But even when we had to change out batteries and the cost of that, we see the batteries now, it's not some kind of mystical type creature. They're in a lot of ways just like a filter, an oil filter. We don't worry about wearing them out. I mean, we don't want to wear them out too fast, but just like an oil filter on a diesel, eventually, that gets full up of stuff and you've got to change it out and put a new one in. Well, that's the same with batteries. They're filtering that kind of renewable variable power that we get from the wind, and they kind of help keep it on our system as in a lot of ways like a electronic filter. And from that, once they get worn out, then they're cost effective enough that we could change them out again and be fine. I'd rather not have to do that, and they're operating great, and we don't have any near term to do that. But it's not a scary thing that we thought it would be first getting into when we'd have to change batteries. We thought it'd be just awful. but it wasn't all that bad having to do the cost. The costs are going down on these things all the time. So. And this is a picture of, we also have 2 flywheel energy storage systems as well. And they're pretty unique machines. And so they're mechanical. What happens here is you just got 13 tons of steel spinning at 3,600 RPMs, and it's connected to a little electric generator. So you just use that momentum to make electricity. The good thing about these is you can do them all day long. And there's times we'll hit these things and ask for power 2,000 times in a day. And they can do that all day long because they're mechanical and it doesn't wear them out. Every time you ask something of the battery, it takes a little bit of life out of it. So what we have is these things go first, the batteries go second in case of a need, and on from there. And also what these things do is we have a large shipping crane on our island that Matson Lines in the city really wanted to put in. And it's an electric load that it was originally going to go to Anchorage, and it was you pick the box up, you use a couple of megawatts of power to do that, and then you drop it back down on the boat, and it injects about 1.5 megawatts of power back in the system. Well, our small grid doing it once 2 megawatts and putting 2.5 or 1.5 megawatts back down wasn't much of a stability problem, but doing that for 8 hours straight, one box after another, would have worn our system out. And so these flywheels basically directly couple electrically with the crane when the crane's in operation. And when the crane needs power, the flywheels inject that power to them. And when the crane sends power back to the grid, these flywheels grab that power back, spin it back up, and our system sees very little of what's happening from all that. So these machines have been awesome. Very low maintenance, great machines all the way through. They're an ABB pillar flywheel system. And it's owned by Hitachi now, but that was originally who they were. So that's kind of how our system works in general here. So we've got to keep 60 cycles, just like everybody else, in the US does. From that, you've got your loads going out, whether it's seafood processors or Coast Guard or whatever. And then you've got coming in as Terra Lake. Terra Lake is, again, our cornerstone, good base load power that we can, and base load by meaning we can ask for something that's going to give it to us. It's controllable. The wind turbine just gives us what the wind turbine gives us. We can do some control on it, but we don't do that very often on that. Then we have, in normal times, what we have is we have the batteries and the flywheels watching that 60 cycles. And if it gets too far away from the 60 cycles, the flywheels inject power first. And if it's still getting even further away, the batteries will inject it next to try to help keep that system stable. We, knock on wood, now we've had wind turbines for 13 years now. We've never had a system outage where the frequency has gotten out of control due to the variations of the wind power. So we've been able to keep it stable from that. And when the crane's in operation, the flywheels stop looking at the grid and they just look at the crane like I talked about before. So that's kind of how our system works in a lot of ways right there. So this is the kind of the timeline of what we've done. And I think it's one of the things that's worked really well for us is we didn't try to do it all at once. It's been a bit of a process over a long period of time to get where we really are now, which is very comfortable. We have surplus power. We have the interruptible power I've talked about, and we have really stable, everything's just really stable all the way through. So kind of looking back, we started this process. You saw we passed that vision resolution in 2007. But that really started a couple of years beforehand. We just weren't really ready to commit to that 95% yet, but that feeling started a few years beforehand. And really kind of looking back, one of the big steps from this, and you'll kind of talk about policy, and nothing negative with the RCA at all, but we were doing a lot of steps we didn't fully understand anywhere in here. And some things were pretty timely in here as well, that we had to do at a certain amount of time, and you had to go quick in certain situations. So we became locally regulated. And there's a law inside the Alaska. If you're a cooperative owned by your community, they can vote you out of state regulation. So our community back in 2004 voted us out of state regulation. And so we're locally economically regulated here. And that's gone pretty well for us. Again, nothing negative with the RCA. We weren't mad at them or anything like that. It's just we're very nimble now to make moves. So We jumped in, did some upgrades to our hydroelectric plant to make it respond faster. That's that governor upgrade. We also, as I kind of briefly mentioned before, wind turbines can be really kind of funky with voltage a little bit, not to get too much on the electrical side, but our system, our fish processors are also kind of funky on voltage, but they were the opposite kind. So they would have kind of hurt each other a little bit. So we work with some of the fish processors to kind of help get that system power factor voltage up, a lot of capacitor banks and all. And then speaking of being nimble, trying to do all this stuff and having someone else own your hydro plant, because they want to operate it in one way to maximize their needs, which I get, nothing wrong with that. And we wanted to operate it in a different way so we can maximize all our resources together. We really pushed and worked our way out and purchased Terra Lake from the Fort Dam Pool Power Association back in 2009. So that's been very successful for us as well. And at the same time, I think Copper Valley got theirs, and they're independent now. And then SEPA then was formed, and they're Wrangell, Petersburg, and Ketchikan, and that's kind of what the left of Fort Dam Pool from those days. So then in 2009, also it was a pretty busy year for us. We put the first 3 wind turbines in. We did a lot of modeling and stuff beforehand to see how this was all going to work on the system. That's what drove some of those other upgrades, system power factor upgrade and the governor upgrade before. And then we knew we wanted 9 megawatts of wind up there, but we knew we couldn't do it all at the beginning at once. When we first put the first 3 wind turbines in, we curtailed a lot. We were very conservative with how we ran them, and we really wanted to understand what was happening quite a bit. And we knew the solution to get 9 megawatts was a battery of some sorts. And we started working through that process, a lot of modeling, a lot of engineering, and eventually put in the batteries. I talked about 2 1.5 megawatt battery systems. And then we put in the additional 3 wind turbines right after that. And then that was all working great. And then to finally maximize everything out of the hydro plant, we put in the final 3rd turbine at Terra Lake. So it took it from basically a 20 megawatt to a 33 megawatt plant. And that way we could kind of, because a lot of ways the hydro plant acts as a really big battery out there. And that made that big battery 50% more robust. And then a year or so later, just kind of put icing on the cake. The Madsen and the city really wanted that crane installed, and we all partnered up together. They actually helped contribute to install these flywheels, and we put the flywheels in 2015. And then we started to, and we kind of knew this was coming, but as load was continuing to grow, our resources, our renewable resources were starting to get pretty tight. So we did the Upper Hidden Basin Diversion Project and finished that right at the kind of end of 2019. And that's given us now a surplus of renewables, and we'll be able to have those interruptible loads and all that kind of stuff right now.
Hey,
So,
Darron, going back to your windmills, you put the first ones in about 2013, and then 3 years later, you added the other 3. Or did you go back to the same company and use the same type? They look very similar.
yes. Yeah,
Okay,
they're all 3 GE, or they're all 6 GE wind turbines. They had a slight design modification between the first ones and the second ones, but they're very, very similar units.
Okay.
Yeah,
Just
yeah,
curious.
we've been pretty happy with the GE units. They've operated well. There's a lot of other good units out there, but they've been pretty good for us. So,
All right. Thanks.
sure. So from a kind of engineering, just kind of, I like this. I'm an engineer by trade. This is kind of really the nuts and bolts to show how it all works and effective. The trick with this variable renewable power is just keeping that frequency stable and keeping the lights on. And that's what a lot of concern from utilities have, very valid concerns, because you can't ask wind power or solar power. It just gives you what it gives you in a lot of ways, versus a hydro or a diesel. You can tell it what you want and it gives you that for the most part. So kind of just explain this slide a little bit here. You've got this orange line kind of in the middle. That's system frequency. So 60 cycles is perfect. If you get too far out of whack, you start, in our system, lights start to go off. And then, so that's, and I'll explain that here in a little bit more. This dark blue line, that's Terra Lake, how much power was coming out of Terra Lake. The lighter blue line was the wind turbines. And then down below, we have the flywheels and battery energy storage. And this was just shortly after everything was kind of installed with the flywheels and all. And we're going along just fine. We had 19 megawatts on our system. So kind of about an average load day, nice winds coming, 9 megawatts of wind, everything's stable, 10 megawatts of hydro. They're working together great. And all of a sudden, the wind just goes away over a matter of just seconds. It wasn't like it was the wind power tripped off or anything like that. It's just the wind was blowing 25 miles an hour, then it went to blowing nothing. And just a matter of seconds, and stayed that way. We don't get that very often, but it can happen up here. So our system starts to respond. And again, our customers need 19 megawatts. And if they don't get 19 megawatts, that's what they're asking for. We have to supply that right away. So what happens, we're running shy of that. So you'll see this orange line start to go down because we're not supplying as much. As wind power goes down. Our hydro is picking up, but our hydro plant, the way it's designed, you saw the picture of the lake, and then you got the power plant. Well, in between the two is a 5-mile tunnel. So just hydraulically, you just can't just say, hey, give me all this much more power right away. You'll end up with some hydraulic problems in the tunnel. So it takes 60, 90 seconds to really kind of get that plant spooled up to do something like this. So that's what our flywheels and batteries do, is buy us that 1.5 minutes, 2 minutes, 3 minutes of gap in time to give our hydro a chance to get caught up. So what happens, frequency starts to go down. And being in an islanded grid, we have more fluctuation. You couldn't do this on a lower 48 grid. You probably couldn't push it this far on the rail belt grid. You could probably push it farther on the rail belt grid than you could in lower 48. We have some more elasticity in our frequency than others do. So we use some of that. Frequency starts to go down. Well, now, if you remember, the flywheels and the batteries are looking at frequency. That's what their job is in life. Flywheels say, hey, there's a frequency problem here. They start to inject power out. And then the batteries are going, oh, frequency's still going down. It's gone to my point now. The flywheels couldn't handle it. Batteries inject power. At the same time, Terra Lake is going, I'm going as fast as I can. It can finally start to turn around some and help start picking some up. And this is in about 40 seconds or so from the wind dying down. And then the batteries are giving all they can. We've retuned the flywheels a little bit, because the negative with flywheels, the positive is you can hit them all day long, 2,000 times a day. The negative with flywheels is they're very short life of energy output. Ours run for 1 megawatt for 16.5 seconds. That's all you get out of them if you run with full load. And so the batteries can go right now 15 minutes at full load for 3 megawatts. So that's the strength of batteries, but the weakness of batteries are you just, every time you hit them, you lose a little bit. But the strength of flywheels is you can hit them a lot, but they don't have much energy. So we try to marry those two and let each one of them cover the other one's weaknesses, which has been a pretty good way to do it. So now frequency, Terra Lake's risen enough, the batteries and the flywheels have helped enough. Frequency slows down and starts to speed back up again. The rate of decline slows down, starts to speed back up. Batteries see that things are getting better. They start to peel off, and away you go. The hydro is now caught up, and in a matter of another 200 seconds, system frequency, everything is stable. It's like it never happened, except the wind is now gone, because whatever reason, the wind speeds went away, and the wind just was, obviously wind power just died along with it. So this also showed this point right down here, which is just about 58 hertz. If we'd have gotten just a little bit lower, we would have started cutting off customers. And so we knew we had kind of really designed this as far as we could go. We really couldn't add more wind to the system under this configuration, anything like that. So in some ways, it made us feel really good that we had really dialed in as far as we could get and get as much out of this system as we had, because things don't get much worse than this, having basically 50% of your system load just go away in a matter of just a few seconds. So,
Darryl, do you actually have standby diesel generators online that you can bring online?
We have standby, and they're hot standby, but they're not operating. It would probably take us, 5 to 10 minutes to really get those operational and going. And they're manual start. We don't have them anywhere automated to start in kind of any kind of situation, anything like that. So, yeah, they're not. The reason we really keep the diesels on board is our hydro plant is about 20 miles away remote. and the power line goes over a mountain pass into town. And just like Juneau had several years ago, we can get heavy icing and stuff up in the mountain pass on our transmission line. So we run a full fleet of diesels here in town, or we have a full fleet of diesels here in town that would provide backup in case Terra Lake was unavailable for a long period of time. So,
Sure.
yeah, but we only run those basically quarterly to make sure that they work. So just kind of a number we've used. We estimate $3.50 a gallon for diesel fuel over time. Again, if you use $5 now, it's even much higher. But fuel prices all over the place. But it's $70 million. And even the cost of the project, even before the grants, was at 40 million, 45 million. It's been a big money saver for us all the way through. So if you remember where we were in 2000, and now we've done a lot of work on a hydro to increase our hydro, operating basin, other efficiencies, things like that. We've got the wind, and now we just have this small little slice of diesel, and primarily that's just every quarter. We just run the diesels to make sure they work. So that's where we are on the renewable side. We're basically 100% renewable, 99 point whatever. But the other great thing on the other half, going to our vision statement, there's the first half. We're going to be 95 plus or 98% renewable. The second half is the cost effectiveness. So this is not inflated dollars, none of that kind of magic inside there. If you remember here in 2000, you bought 600 kilowatt hours of power as your residential house, your bill would have been $106.38. Earlier in 2022, you bought the exact same 600 kilowatt hours of power, your bill would be $103.24. Our rates have basically stayed flat. We've not had a rate increase since the 90s, and we don't project one anywhere here in the near future. So our rates are just over 16 cents a kilowatt hour for residential, and that's what they were in 2000, and away we go from there. And hopefully this stays this way for quite a while from there. This is obviously something that's made our membership incredibly happy. A couple of things from this: obviously it's more cost effective than it was. And then two, the biggest driver we had starting this was variability in power costs. And now our power costs don't vary really at all. So it's been great. We really achieved the missions all the way through, and the membership has just been incredibly happy, especially in days like this where 8% or whatever inflation on everything else you buy, and electric bill is $100 a month for the average family here in Kodiak. So it's been pretty good.
So what is your rate for your commercial rates? I'm assuming you have different rates for larger commercial.
Yeah, it's going to be, I can't remember those off, depends on what size of commercial stuff. You're a penny or a couple pennies less than that per kilowatt hour. And they have some demand charges built into them as well, that just like any other utility.
Sure.
And so I think you may be 3 or 4 on the large commercial, 3 or 4 cents a kilowatt hour less. And our demand charges are pretty small. They're like $3.50 for per kilowatt versus some of the others get up pretty high. And that's kind of the luxury of how we built the hydro plant as well. So, and those rates haven't changed either. The same proportion would be there for them. Large power, 2000, their bill might have been $10,000 or whatever some large power customer would have been. Well, it'd be $9,950 today. Everybody's rates have stayed the same.
So with those low rates, especially for commercial, have you seen an increase in expanding the commercial side, especially in the fishing industry? Have they expanded their operation at all because of the lower rates?
Yeah, we did have, particularly Trident Seafoods made a huge expansion here back 4, 5, 6 years ago. And they went to much more automated systems. I think they spent about $95 million in the community with a big expansion from that. And we definitely heard that part of that was the stability and the cost of electric rates. It's not the number one cost they have, obviously, like labor, cost of fish and things like that. So but it's not causing them a problem anymore. It definitely caused them a problem back in 2000. There was a lot of concerns from that, but they were able to help. It would help them expand because of the way our electric rates are now.
Yeah, good.
Darron, what kind of growth capacity do you have in this system, and do you have plans? I know that you got the bypass in the works. Do you have plans to increase the renewable portfolio for growth?
You know, right now we've got kind of ample with our hidden basin. We've got ample right now. We're going to be spending a lot of time talking this winter. How long do we think this ample is going to last? We're hoping it lasts till about the time that we need to look at replacing the wind turbines. That would be great. You can't control all that though. One of the things that's kind of accelerating our load growth is these high diesel prices. So it's in a lot of ways it's awesome. In a lot of ways it's scary that with these prices, they're seeing electricity as a solution. Heating, and this is large power heating or it's residential heating. So we're getting a lot of heating loads coming in to our system, and we'll make sure we stay ahead of that because it makes no sense to run a diesel to provide electric heat. Very non-thermodynamic efficiency that way. So we're trying to keep an eye on that. You know, this year we're fine. Probably for the next few years we're fine, and we're trying to study is that 7 years or 12 years do we have left? Most likely, if we had to expand right now, we'd probably be looking at expanding our wind plant and getting more wind energy. Probably have to adjust our batteries a little bit to make that happen. And we've got potential to be able to do that. The new wind turbines today are 3 megawatts instead of 1.5, so we could probably get expansion that way in some form. Hopefully, we can get 7 more years of wind usage out of these current wind turbines before we have to look at doing that, though.
Are you obviously with the wind turbine expansion, that ratio of wind power to hydropower changes, but are you looking at things like dispatchable loading for space heating to control some of that additional wind?
That could be. We haven't got too far into the engineering yet on it, but one thing we did do, so like that curve before, I'll go back to it. So this was built before Hidden Basin. So now as our load grows, our load growth for the near future is going to be handled by hydro. So hydro is going to be becoming a bigger and bigger piece of this. So that will allow us more ability under the same system to put more wind in to keep that ratio the same. My guess is we'll probably have to tilt that ratio a little bit more in the favor of wind when we do an expansion. So yeah, dispatchable loads could be a part of that, especially with if it's electric boilers. Those are very easy to dispatch to an extent. And so that might be part of the puzzle. We've talked about it some, but we haven't gone there yet. But we might play around with some of that in the interruptible loads we have, which are all on electric boilers now. So we've talked about it. We just don't have to use it yet, but we might start experimenting with that in a couple of years just to understand how it works better.
And one more quick one, and I'll be quiet then. As far as the space heating scenario, and that makes perfect sense as people want to move off of diesel for that solution. Are you having any voice in the type of space heating? Are you looking to encourage things like heat pumps that are maybe a little more efficient on the electric end?
We've tried to encourage heat pumps. The concern we have, and we try to encourage, it's not so much the resident. The resident will be great with a heat pump. They're a little more technical to put in, and we're trying to encourage the heating companies here to get more engaged in those because they do take different kinds of maintenance and different kinds of understanding. And we've seen a few heat pumps here that have been installed not the best. And so then all that wonderful efficiency you get out of a heat pump, if you don't install them right, you lose it all. And even worse than that sometimes. And we've seen some of that. So they don't, unfortunately, for some people in town, don't have the best name. And you get an electric boiler, it's easy to install. Everybody understands it. You've already got the baseboard heating in your house. It's simple. And so we've just kind of stayed out of that discussion. We provided people information. Here's the efficiency of a heat pump system. Here's the efficiency of the electric boiler system. But as long as you're going over to full electric, we actually provide an incentive for that. We give you a discount on your bill for a while, a credit, if you go full electric and take out your oil. So we're kind of agnostic on it. I mean, from the engineering side, I'd love everybody to get heat pumps. That'd be great. But trying to push that issue, we started a little bit on that, and it just wasn't successful. So we just kind of backed out of that.
Darron, can I ask you a follow-up question on that? Maybe sort of the law of unintended consequences part of all of this is what's happened to the diesel market in Kodiak. So there's still people reliant on diesel. And what are you seeing with regard to the pricing for diesel in Kodiak?
I'm not sure how much it definitely, we were an anchor tenant that's got taken off. We've taken a lot of the school district off now, but I think the big anchor tenant in the community is still the fishing fleet. And that has not changed at all. So I haven't heard or seen any big negative ramifications from us going off or the school going off. Because again, I think the big anchor tenant is the fishing fleet that keeps everything moving from a fuel standpoint here. But that is something that, as this goes on further and further, that's definitely the back of our minds. Hopefully that doesn't cause a bigger problem on down the road for the 10 or 20% that are left using diesel, and all of a sudden diesel's now twice as high as it used to be because of just supply and demand reasons.
Just anticipating that sort of price disruption scenario comes at some point, and people are anticipating it,
right?
Rather than just it happens to them and they're like, we don't. What happened here? We didn't anticipate. So, okay. I guess go ahead.
Well, I was just going to show you that we talked about Upper Hidden Basin diversion earlier. Y'all mentioned Battle Creek. Here was our version of Battle Creek, lack of a better word. So this is Terra Lake. You saw the picture earlier. And then, sorry. So we diverted these two streams, these upper elevation streams, dug a 1.2-mile tunnel through the mountains, and that just flows into the lake. Again, a very similar kind of concept to Battle Creek was, and it's been on for a couple of years, and it's been very beneficial to us. We've had a couple of dry years in there, and otherwise we've probably been burning diesel, but it's been able to allow us to even increase our lake elevation just because we added water. It added about 25% more water to our system. It was about an $80 million project, and it was not a grant funded project. It was very expensive, but you build it, it's going to last 1,000 years. So it is great from that standpoint. And then there's just a couple pictures of the diversions we put in the far right-hand corner of this picture. You see the tunnel inlet. It's a 11-foot diameter tunnel. And there's just the water flowing out as it goes to the lake. So pretty minor from an invasiveness standpoint, and no moving parts. So just a good long-term solution there. And then finally, just wanted to mention that in 2017, we'd had the same vision statement for 10 years. They modified it since we'd already basically achieved 100%. We need to stay at 98%, and we still got to stay cost effective. So that's our running vision from here on out, is to stay at least 98% renewable from here on out. And that's what I've got, unless there's other questions or anything.
Great. Well, yeah, let's see if there are any other questions online. You can use the chat feature, or you can open up your camera or raise your hand, do any of those kinds of things. I do have a question for you, Darron, in terms of, the cost of capital for doing projects like this. You just mentioned the diversion project at 80 million. I think you said, I can't remember the pricing on the wind turbines, but at any rate, and you've mentioned the importance of the renewable energy fund. How for a small sort of fixed market electrical utility, financing these kinds of projects would be under most circumstances not within reach. So how important has the renewable energy fund or other renewable energy granting mechanisms or incentives been in terms of putting these things in place?
Incredibly, we wouldn't be here today. We would have wanted to do all these steps, but it would take us a lot longer without those programs, and would have been obviously a lot less savings too. So the two big programs that have been there, the renewable energy fund from the state, that helped us tremendously on many of those projects along the way. Just the timing for us was just impeccable with that. And at the same time, from a Washington, D.C. standpoint, they passed the Energy Policy Act in 2005, and buried inside that was the ability for co-ops. You kind of had to jump through some IRS hoops and stuff like that. But a lot of what we had to borrow, we borrowed at just a little over 1%. There was basically an IRS subsidized interest rate. You go to your own bank that you typically use, and then you get this discount to the IRS. It's a very convoluted process, but once we got it down, it was very effective. And so most of our debt for all this, not all, but most of our debt's in the 1.5% range. And then we got a lot of grants from the state at the same time through the Renewable Energy Fund. So we would, if none of those were there, we probably wouldn't have Hidden Basin done at this time, because we'd had all that capital had to go back into the other projects to make that happen. And we'd probably be running some diesel right now and our rates would be higher. So it's been, those were both very effective. I think it's great that we have loans that are, skin in the game on it, but both those policies federally and state were incredibly helpful through this whole process.
So thinking forward though, like for example, replacement costs for turbines or what have you, are you going to still be reliant on that, or are you going to be able to do that off your balance sheet? How will you look at financing replacement costs in the future?
Well, it really depends on what the timing is on it, and what the costs are in the future. It'd be wonderful if they were having new programs out there at the time to take the edge off, because going out and we had to put in, we had to take these 6 wind turbines down in 12 years and then put up 6 3-megawatt units. That is a lot for our community to take on, whether that's assistance in loans or grants or combination. It's difficult for our size utility and our kind of balance sheet to do that. And that's probably the same for probably a lot of last utilities all the way through. So that would be good. We're being very aggressive on our debt payments and trying to hope to get a lot of our debt down in time, so our balance sheet is prepared for that. But you never know how the timing of everything is going to work out for that as well. So
Great, thank you. Any other questions from the audience? Bernie, Marianne, anybody?
Darron, this is Bernie again. Riley Lake has to operate with the fish coming out of the lake. Does Terra Lake have fish, and do you have to abide by fish and game like Riley Lake does for having a fish count?
yes, very much so. So if you just downstream of this dam, there's what's called the Terra River. And we have probably 20% of our water goes down this for fish management.
Okay.
So it's pretty substantial.
All right. I was curious.
Yeah.
All right. Thank you.
Great. Okay, well, I don't see any questions in chat or anybody raising their hand or turning on their camera. So I think you've answered everybody's questions, Darron.
Okay.
So we want to thank you. I'll toss it to Bernie here in a second, but I am going to do a couple of commercials before we leave. We invite you all, of course, to join us next week, same time, same channel, for a session with Launch Alaska about the Arctic Road Rally. And let's see, sorry, excuse me while I bring up this slide. And we also want to make sure that we send out one last invitation to the Hickel and Egan Awards, which are this coming Monday, October 10th at 5:30 at the Denina Center. We'll be honoring Eric Wolforth and Diane Kaplan. So just wanted to send out that reminder. And again, we'll have Tim Leach with Launch Alaska here next week about the Arctic Road Rally. Tim's with us. Hi, Tim. How are you? So we'll see Tim next week and hear about the Arctic Road Rally and using electric vehicles on an epic trip up the Dalton Highway to Alaska's North Slope, and the challenges of putting all the charging infrastructure in place to make that happen. So please join us for that. Do register for it if you haven't already. Check out the events calendar at commonwealthnorth.org. And with that, let me turn to Bernie to thank our guest and sign off. Bernie?
Yeah, I really appreciate this. It was a very timely and really detailed report on how Kodiak has become just an amazing utility. This is it's the hope of every utility to be 100% renewable and get off of diesel, or in our case, in the rail belt, curtail the natural gas, which may become a problem in the future. But yeah, thank you very much, and I hope you keep on going.
Thank you very much, and thanks for all the great questions. It was good. Thank you.
Thank you.
Take care, everyone. Bye-bye.
Bye-bye. Thanks, everybody. Thanks.